Hi, everyone, and welcome to our AI at that Works conference. My name is Dzmitry and will be the host of today's session. And a few minutes ago, you have probably been there. So we have opened our conference, and let me introduce our first talk for today, where our speaker will walk you through all the new EliteA platform capabilities and will use AI agent to test cases generation as a practical example. This talk will be focusing on how we can do more with less LLM. So let me introduce our speakers, Dzmitry Shaplyka. Hi, Dzmitry.
Yep. Hi, Vyacheslav. Hi, everyone. Good day.
Nice to hear. Nice to see you here in the conference. And dear listeners, please feel free to post any questions in the chat during our session, and we will address them in the end to our dear speaker. So, without any further delay, let's get started. And Dzmitry, the stage is yours.
Yep. Hi, everyone. One more time. My name is Dzmitry. I'm Quality Engineering Manager, AI Ambassador, AI Practitioner, and EliteA user. And just to not waste the time on my introduction, let's go to the next slide where I quickly share the agenda for today, and then I will stall my screen and will present the demo itself. So first, we'd like today to approach the test cases generation, pretty classical use case in software testing world, but from a bit different angle where we would like to minimize using of LLMs, trying to deal with some big context, share some EliteA features, but again, so I will present the demo using EliteA application, but the approaches might be reused and useful for other agentic tools. So this is not about EliteA itself. I will provide the suggested solution, will do the EliteA demo, and then there will be place for the Q&A. So we're pretty tight in time. Let's jump to the kind of topic itself. Let me stall my screen. Please let me know if you can see it.
Yeah, we see.
Okay, I hope you can see it. Let's start. So, as I said before, today we'd like to speak about the classical example, test cases generation, but from a bit different angle, using recent EliteA features and capabilities. And our goal is to chase the following kind of things like reducing LLM usage, handling relatively large input data, decomposing the one agent into set of sub-agents or sub-nodes, and use such classical approaches like human in the loop, source grounding, and LLM as a judge, and others. Okay, during this demo, I will present the agent that is inspired by the real agent, like that we implemented for one of the clients at EPA. Because of confidentiality, of course, I cannot share real project details, real data, and so on and so forth. This is why I use some fake data. However, the approach exactly the same, like in production, but a bit simplified and, of course, using some fake data as an input. This is just a disclaimer. Okay, so moving back to the case. It's the following. So let's imagine we have some requirements that we need to put in to the input and some additional information. And we'd like to build some kind of trivial agent that will read those requirements, will cover them with tests, categorize those tests by assigning proper labels and something like that. And of course, output the list of test cases for us. Okay. Traditionally, how we approached it, we had one agent and gave it all data at once. I mean, the whole kind of combination of requirements, some additional information, some template, huge agent instruction, and in one shot generated test cases. Okay, for some this approach worked well, but obviously it has some limitations and problems. First, we put so much data in the context, almost at the limit of context window of the model itself. If we put huge amount of information to the input, we expect some big output. And this is where we also limited by model's capacity, of course. And the last but not least, when we work near those limits, the quality of output become worse. So this is the fact. Additionally, looks like we ask too much from one agent, because actually under the hood, we'd like to analyze the requirements that we put into the input. We'd like to prepare the list of tests. We'd like to kind of categorize or label them. Also, we'd like to ensure that we properly covered all the requirements by tests and, of course, output the result. So that's too much for one agent, for sure. How we'd like to solve it? First, what we suggest, split the whole approach into two stages. First, so-called and pretty popular the plan mode, when we first generate not the full list of tests, but the list of checks, something more limited. Here we ensure the coverage. And only after we are good with this coverage, we can proceed to the generation phase where we extend each check into the properly described test case, including some steps, expected results, some data, and any other important stuff, important kind of sections of the test case. Okay, so then by using this approach, we'd like to minimize LLM usage, like I said before. How? By using technical nodes as much as possible. I mean, we try to separate actions where we truly need LLM and its generative AI capabilities, like generating test cases, categorization, validation, and etc. And action where we can avoid LLM at all, where we can use some classical coding, scripting, or usage of some HTTP requests, reading from file system, and etc. And of course, to make our workflow more deterministic and kind of stable, we'd like to split the workflow into some atomic stages, sub-agents, some sub-nodes. Call it like you wish. And each sub-agent and sub-node is instructed to deal with some particular thing, particular case. So, okay. And let's review the flow quickly, how we kind of approach it in our case. We start with reading the document itself, where we use some toolkit, which doesn't use LLM at all under the hood. This is just technical node, like I said, where we read something from somewhere and the save result. It could be reading from Jira ticket through the HTTP request. It could be reading from the Confluence again from the HTTP request, or it could be reading a file from the file system, something like that. Okay, then the main idea here also is that we don't kind of work with the whole document at once. It means that we'd rather like to split it into chunks and to generate checks for every chunk in separation. And only after that, we aggregate the result. So why? Because again, maybe the information, those requirement document, and the mixture of additional data is too much to fit into the context. And we need to somehow deal with that. And that is why we work with less tokens in the input. We produce less tokens for the output. And the model is more kind of focused on some portion of requirements and can easily cover it with the tests. Okay, how we do that in our case? By using some, again, technical node, subnode, which uses Python scripts under the hood, where we split the document into chunks. In our cases, we split by headers, because we have such structure in our documentation. But for other documents, for other requirements, we can use different strategies that may work better. The key is to choose what fits your data the best, I would say. Okay, so we read the document, we split it into batches, and then we operate for each batch in separation, in so-called loop. And here is where we truly need the LLM, the first step, and its kind of generative AI capabilities, where we'd like to kind of convert portion of requirements into the checklist, list of checks. I don't know, call it whatever you like. We build it here, and then often people ask questions how to ensure that LLM does not hallucinate in the output. And this is where we can use approach which is called source grounding. It means that we not only ask to produce the list of checks for the selected batch, but we also ask for exact citation from the initial document, from the initial batch, that prove us that this check is really needed for this portion of requirements. And we can easily kind of do sort of traceability and ensure that this check appeared not from nowhere, but from the document itself. Yep. I hope you got the idea. Then, after we produce the check, we'd like to do some validation. And this is where we can optionally introduce sort of checklist validator agent that follows LLM as a judge approach. It means that for each portion of checks, we'd like to automatically validate it upon some criteria. Those criteria could be kind of different and unique for each project, for each domain, and etc. But in our case, we just validate that all requirements are pretty much covered here. If everything is correct, we just proceed with the next stage. If we see that if the model sees that there are some gaps, we get back to the creation stage and regenerate the result and do that in sort of loop. Okay, for case that if everything is, I forgot to mention, input in this agent, of course, the initial doc batch and checklist that we generated for this batch on the previous stage. And we'd like to kind of compare them with each other. Okay. When everything is correct, we proceed to the next stage, some categorization. It could be some label assignment or some grouping of tests, something else. But of course, it is done by another separate agent. And this one is only gets checklist, and we instruct it to assign a group, assign labels, etc. Only one action at a time. After that, we'd like to aggregate the results. We can do that using, again, some Python script, etc. to kind of accumulate results for each batch. Once everything is generated and we repeated all the sequence of actions for every batch of our document, we put it for the feedback to the end user. And this is where human in the loop approach appears. Human validates it. If everything is okay, we can proceed. If something wrong, we can kind of regenerate some kind of portion of checks or some or improve some of the items that we can select and etc. So we do some validation here. After that, we proceed to the kind of step 2, where we take each checklist item separately and work in almost the same loop, trying to expand this check into the properly detailed and described test case, containing steps, expected results, data, and so on and so forth. But approach is pretty much the same. We expand test, we validate it upon some criteria, we check this validation, we aggregate, then we provide it for the end user. And after that, we can publish it somewhere in test management system or continue our agentic flow. It depends on what your agent should do. Okay. Hope it was clear for you, but again, this is just a schema. Let's go to EliteA. Let me just run it. Okay. I didn't expect that I will be locked out, but it may happen. Okay. Just a few seconds lost, but it doesn't matter. Okay, so let's run it and I explain all the stuff. While it's run, we can first review the schematic view of the pipeline here and see that it is the same like I presented right now in the mirror. We have some reading stage, document reading stage. We have splitting into chunks. We select particular chunk, and this is where we enter our big loop and sub loops in it. So generation, I will zoom in, validation, then some checker, labels assigner, then we do some aggregation, and we are closed in the big loop where we repeat the same stuff for every check. Once everything is complete, we print the result and then proceed to the next stage, next loop that looks pretty much the same. So, but we operate with each check in isolation and trying to expand it into the test case itself. Okay, so let's review the implementation of the pipeline workflow, how it's done in EliteA right now. But again, so it could be replicated and could be done in almost every agentic solution in a bit more different way, but still the main idea and approaches are kind of the same. So, like I said before, the first step is where we read the requirements from somewhere. In this case, I will use Artifact Toolkit and read this file from the file system. This is just a toolkit without usage of any LLM. And at the right side, you can see the log of each action that our agent performed. For example, we have doc reader, we can click on it. We see that we read some demo doc here, and this is its content. As I said before, this is the fake data, of course, but it looks similar to what we have on the production environment. Okay. We read the document, then we need to split it into chunks. As I said before, we use a specific node, which is called code node here in EliteA itself, but on our other agentic platform, we could use some skills, we can use some scripts, and etc. So, as I said, approach is pretty much the same. We can open it and you see this is just a portion of Python code, of course AI generated and tested in order to get the document and produce the list of kind of chunks grouped by batches for our convenience. So this is just a Python code. We can click on the second step and you see that at the input we provide our document base 64 encoded, and at the right you see the result of work of this. We see some kind of structured information grouped into some batches. Okay. Let me close it and go zoom out. Go to the next stage. We were here at the splitting stage, then we need to select the exact batch to proceed with that. Okay. Okay. This one, again, this is the Python node where we select first item from the array of batches to kind of proceed with some generation stuff later. Only 3 lines of Python here. We again can review it at the right side here. Okay, we selected some particular batch, particular piece of information. That's it. And only for this part of information, we would like to build a checklist. This is not so big, not so huge as you see. Okay, the next, you see that we start getting into loop where firstly face with some LLM-ish work. This is our checklist generator. This is just an agent with some simple prompt written in human readable language. So everyone is able to write and develop such prompt, I would say. This is just an instruction how to convert requirements into the list of checks for this particular portion of requirements with some specific guidelines and specific rules that are applicable, let's say, for our project, but you may have some custom rules, custom test design kind of guidance that could be kind of reflected here. And here we can open this node, and this is where we see the result of execution. So this is how we see the first portion of checklist. I use some JSON-like format because it will be easier for us to handle in later stages where we would like to kind of aggregate it in the big list of checks where we'd like to take some particular check from the list and convert it into the test case, where we'd like to prepare the proper payload for publishing and etc. But again, the format could be adjusted, could be configured, and anyway. So this is how this check looks like. Have the check itself name, and we have the citation. This is exact reference and citation from the initial batch, initial documents, with some section where it could be found. So when we validate it, we can easily go to the document and to kind of match it to see whether it's not hallucinated result. Okay, it was the generator. Then we go to the validation stage. Again, this is the agent with some human readable instruction written in plain text. Here we validate only upon the criteria that we cover all the requirements from the given list. But criteria could be adjusted, could be much more robust, but for demo purpose we use this one. And the result, as a result, we produce something like that. If everything is correct, we just output pass. If something fails, we have some reasons and missing requirements that will be returned for the generator agent in order to regenerate the result for this particular batch, for this particular portion of information. Okay, we can see the result of execution here. So for the first batch, we got pass. Looks like that's okay. It means that we go to the labels assignment. Again, we proceed. We see almost the same checklist as we said before, but with some labels here. So this agent, sub-agent added just some portion of information here. Okay, in our pipeline, it's stored somewhere here, but I missed this important stuff. So after validation, as I said before, we have some condition to check. In our case, we use the node which is called router. This is the technical node that is needed only to kind of route to particular path in our agentic execution. Here we can put the condition. It should be written in some Jinja 2 template. This is some Python feature specifically designed to write some string templates, loops, conditions, and etc. And you see that condition is pretty trivial. If the result is pass, we go to the labels assigner to the next stage. If something failed, okay, let's get back and regenerate. So that's pretty obvious stuff. Okay, so we check, we assign labels like I presented a few seconds ago. Then we do some technical stuff because, you know, we need to kind of process each batch inside the array, and we access each kind of batch by the index. Every time we need to increase this index to kind of do some increment. This is where we do that, increment +1. Then we aggregate our checks into some collection using again state modifier node, which uses Jinja 2 template. And then we go to another router where we kind of validate whether we are inside the route. Again, pretty trivial condition. If index less than batch count, it means that we have batches to cover, and we can get back to the first stage and repeat the loop from the start. If we kind of if all the batches are processed, we go to the next stages. We kind of escape the loop. Okay, this is where we do the counter reset because we use the same variable in another loop that we use in that test case generation stuff. Do some modification because we kind of aggregate those checks. Then we'd like to convert them into one list, fix numbering, fix some format, maybe some issues with that, to kind of clean up some data. Maybe LLM generated some additional stuff that we don't need it. We use again some Python code here just to clean up the data. And once everything is correct, we output it for the user. And this is what exactly happened here. This is how this checklist looks in our case. Like I said, this is JSON-like structure. Yep, where we got some check, we have some citation, we have labels. And as the result of this execution, we got around 50 checks, I would say 55 checks. Okay, here we can introduce some human in the loop, ask for some clarification, some kind of feedback, or maybe regenerate something, and so on and so forth. When we approve the result, so we go to the next stage where we generate test cases. But as I said before, the approach is pretty much the same. We take each test case in separation and go with kind of expanding of each item. Okay. You might say that it looks a bit complicated. I can agree with you. It can be in the easier way implemented in our agentic platform, like Claude Code, where we can use, again, some agents, some skills, some hooks to implement similar approaches. You can do that in Copilot and Cursor and etc. But even speaking about EliteA, where it might look a bit complicated, to be honest, under the hood, each agent, each pipeline, this is just a YAML file, YAML instruction with some kind of description of node, of agent, and etc. And this stuff, to be honest, can be easily adjusted, even generated from the scratch using agentic coding kind of tools like Cursor, Copilot, or something like that. With the kind of current state of EliteA documentation and also having some dedicated skills for building pipelines, we can build something similar from the scratch. We just need to kind of explain what we need, what loops we kind of consider, and so on and so forth. And this instruction can also be generated, copy-pasted to the platform, and run, validated. We can debug, and so on and so forth. So that's basically pretty much it. As a conclusion, I would say what could be kind of useful for you. First, not to try to put everything into one agent. Try to kind of split this information into chunks. The second, if you have one big agent with many abilities, many skills, and so on and so forth, try to split it into sub-agents, where each sub-agent is clearly trained and instructed to deal with particular goal or some similar goals. Yep, do not work with one big agent, but use some orchestrator, sub-agents, and delegate the work to those sub-agents. And the last but not least, clearly define actions where you definitely need LLM capabilities, I mean generative AI capabilities, and where you can avoid using it and use some classical things like coding, scripting, and so on and so forth. Of course, if you'd like to kind of convert one text into another text, I mean requirements into test cases, you definitely need LLM. If you'd like to build user stories from some unstructured information, you need to use LLM. But if you'd like to parse some JSON or restructure one format to another, you can use kind of scripting, coding, you can implement some custom skills and delegate this work to them. So that's pretty much it from my side. Hope it was kind of useful for you. Thank you very much for your attention. Looks like that's it from my part, and I will be happy to answer your questions. I will stop sharing my screen. So,
Dzmitry, thank you so much for the very interesting talk, and I personally gained a lot of experience after this talk, and a lot of practical advices that I will start to apply in practice. We have received a lot of questions. Let me quickly share my screen. One moment before we start Q&A part. So, guys, do you see my screen? Can you confirm?
Yep, you can.
Okay, cool. I see slide with Q&A.
Yeah, cool. Thank you. Yeah. This is QR code, and also I share the link in the chat. Please follow the link, and your feedback really matters. And rate our event and give a badge to our speaker if you enjoy the talk. So this is very important for us to understand whether the talk was interesting for you. So now let's start our Q&A part. We have a lot of questions, and thank you for voting for them. So I will start with the ones that collected more votes. Yeah, the first one. Dima, by splitting the document into chunks, does the LLM lose some context from previous sections that might be crucial for test case preparation?
So actually, we validated both angles. Yep. So where we just provide the batch itself without the knowledge of previous generation, and with adding this knowledge from previous generations. And for our specific example, it kind of didn't affect us, I would say. Mm-hmm. But if you see that LLM lost focus or kind of tries to covers something that is not relevant for this particular portion, you can add as an additional context this information from previous runs. But here again, we should be careful, because with each kind of circle in our loop, the context will get kind of bigger. But in short, for our case, we saw that just adding batch itself without additional information worked for our case. If we miss something, we have additional validation at the end of the generate. When we have all the list of checks, we can validate here, do some deduplication, some maybe aggregation of similar checks that appeared, for example, in different sections of our document, something like that.
Thank you.
Hope I answered.
Yeah, hope. Yes, and let's proceed with the next question. What are the examples of the criteria of good test cases for the test cases quality checker?
Again, so this could be unique for each project, for each domain, and etc. Because in every project that I saw before, every tester writes tests a bit differently. Yep, someone likes some detailed approach, someone likes just high-level information and something like that. But we could use some general stuff for the AI validation, like correctness, completeness, overall quality, and something like that. But again, some criteria could be unique for your particular project, and you will kind of clearly define them.
So you can specify what you need and provide some examples so to tune your agent how it should work for you.
Yep, exactly, for sure.
Cool. Next question, interesting one. How are these test cases used afterwards? Does it really make sense to generate test cases instead of directly generated automated tests for the most critical ones, while passing the rest directly to an agent that can execute tests and provide test results? Maybe more complex thing.
Okay, this is, first and foremost, this is a good question, and that's a good point. But again, so as we use some real production case, we created cases for manual execution, because specific of this domain and specific of this particular project that they use manual tests kind of in almost every stage. And for this team, for this case, we generated this stuff, okay, because they do not use automation. But of course, it could be kind of done in your way, and we can easily skip those manual tests part and generate some kind of test automation scripts that could be kind of run, executed, and etc.
Yeah, so I believe that the practical experience that you shared, it was just to solve particular business problem, and it was solved thanks to AI, and you shared with us.
Yep.
For the rest, for other business problem, it can be also used some other probably approach, but based on these recommendations.
Yep, sure.
Cool. Next one. Do the agents upgrade their skills when doing through the review feedback loops? How's the number of loops limited for a particular step?
Sorry, looks like maybe I don't get this question in the right way, but again, so amount of loops depends on the amount of batches that we can kind of run through this kind of agentic workflow. So speaking of some knowledge, looks like this is something like we answered in the very first question. Yep, because in my particular case, validator doesn't learn from the previous runs, but it could if he produced the context of the previous generations here. This is just the matter of configuration of agents and the matter of what we produce as an input here. So.
Okay, Thank you. Hope we answered the question. If not, Anna, you can drop the question or raise a hand. We can unmute yourself. We can unmute you and you can ask. Next one. How we improve? Can we improve the quality of test cases for the project where there is no comprehensive documentation and only brief and superficial feature descriptions are provided in Jira tickets? This is pain of any QA, I believe. How to overcome garbage in, garbage out rule?
Okay, so that's again pretty good question, and I don't have a universal kind of answer for this at the moment. But on this particular project where I'm currently in, and this example from there, basically the problem is pretty much the same. The input information, some document, is kind of unstructured and not full enough. Just, let's say, high level description of the feature itself. Just put some details. What we do in this case, but this is our approach. It could be different for yours. First, we try to structure those requirements that we got at the input and produce something valuable, highlighting some missing areas, some gaps, some contradiction, and so on. So we do sort of requirement analysis here. After that, we explore additional artifacts because, you may have some bad requirements, but as a testers, you have some knowledge, some additional artifacts that could be useful. For example, some risk areas, interaction with other features, some domain knowledge, and something like that. And this stuff must be used, I would say, and actually in our case, we use it to kind of fill this context, to fill some gaps in order to build some relevant checks, relevant artifacts at the end. Something like that. But of course, each stage should be validated. If you see some gaps, those gaps could be addressed to some proper people, particular people from your projects and so on. Something like that. But again, there is no universal solution.
Yeah, cool. Thank you. Guys, we are running out of time. We have just 2 minutes left. I just wanted to say that another talk will start in 2 minutes. Yaroslav Ubozhenko will present a demo how to combine team knowledge, task management, and AI agents in one place. So if you want to join it, please, you can switch to this talk. For those who want to discuss more questions here, so feel free to stay here and we will proceed with the questions, okay? Let me find other questions. Maybe someone would like to raise a hand, guys. Feel free to do it and ask verbally if you want. No? Okay. Oh yeah, I see 2 raised hands. Maxim, you was the first. Go ahead.
Maybe
Maxim, we don't hear you.
Cannot unmute yourself because I see that all the participants are hardly muted. So.
How about now?
Oh, maybe right now it works. Yeah. Maxim, try one more time, please.
Yeah. Okay. Thanks. Thanks for the presentation, Dima. I just have a bit general question. You have one of the steps you have is the agent validator. It can be sub-agent, it can be some sub-process. My question is, how do you approach a selection of the LLM model for the validator? Should it be just a bigger model than the one which is used to produce the original results, or just a bit more advanced model? Like, I'm curious about your approach. How do you select the right model for such processes, like a validation of already generated results? Thanks.
Okay, now, of course, you need to experiment with your data, but in our case, I would say that for the generation, we use the Sonnet, but for validation, we used Haiku. Something like that.
Okay, so a bit smaller model.
Yeah.
I would say not a bit, but okay.
Smaller and faster and designed to produce some kind of limited output and structure ones. So.
Okay. But did you use any techniques to choose this exact model? How did you choose it?
This was just an experimentation in our case. We needed some fast validation because, if you use Sonnet, it will kind of do some reasoning, then it will check it, then only it provides some data. In our validation approach, I don't need reasoning at all. I just need to have some results, some verdict with some reasoning. You mean with some small explanation. And in our case, Haiku did better in this case.
Okay, yeah, makes sense.
Okay, thank you, Maxim, for the question. And Diana?
Yeah, hi guys. I have a question, first of all, regarding the domain. Could you please unhide it if it is not a problem, just for understanding?
In our case, it is game testing.
Okay, thanks. Yeah, then automation wouldn't be the best option. I was just wanted to join the question from Denise. How long does it take to build such a pipeline from scratch? Well, he's interested. I'm interested also in the pessimistic estimation, and well, probably a small extension to that. What is the approximate price of building and usage of such agents, and how efficient is it in comparison with mentoring and teaching new testers?
Okay, so for this particular agent, I cannot say regarding some metrics that we calculated, some results and etc., because this is an ongoing process. We just build it, we started adopting it, and we currently are do some measuring, I would say. Speaking of building such pipeline, of course, if we are aiming to build it manually, step by step, using UI, it may take several days up to 1 week. But as I said before, right now we have some skills and we can implement it using other coding assistants, and it can be done within 1 working day, I would say, from the idea till the kind of some demo implementation, I would say, and covering all the kind of integrations that we need and etc. Speaking of again, returning back to the measurements, I was a part of one POC that we did for another clients, where we introduced quite similar agentic approach on test cases generation. And we observed that after 3 months of adoption, every test case generated on the project was done by this agent. So QAs just delegated this stuff for the agent itself. They published them in the kind of Azure DevOps and do some post-validation there. But for me, this is the good sign that all the test cases were generated with the help of agents after some period of adoption time. So hope I answered your question.
Great, thank you.
All right, we have one more raised hand, Sergey.
Yeah, thank you very much. I will try to be really quick. Any recommendations for the business analyst? Should they change the approach of documenting the acceptance criteria? I'm already thinking about such things like do not use it, that, which, but every time mention the specific entities to avoid ambiguity for the LLMs. Any other thoughts how the business analyst should change the approach to formulating the acceptance criteria so that agent would pick up them and process them more efficiently? Thanks.
Okay, so that's a good question, and it's a bit about sort of kind of prompt engineering or context engineering, I would say. So as I am not a business analyst, again, I don't have a clear answer at the moment, but try, okay, some specific instructions and important stuff that almost everyone misses. Provide some few shots examples, or write in the prompt or some additional data on how you'd like to see your final output. Just several examples of this was my input, this is how I get the output. Several examples and try to LLM to repeat it. Play with different models, try some reasoning, play with the reasoning section, and so on and so forth. But
Dzmitry, thank you very much, and sorry for interruption. My question was a bit different. How the analyst should change their approach to documenting the acceptance criteria? This will be the input for the first step. So should we reshape the acceptance criteria documentation in any way?
Okay, so I get your point. Like everywhere, I would say that indeed it should be some AI-friendly approach where we put in one place all the details that we need. Do not refer to kind of other sources, try to, describe something in one place so that LLM can understand its context and etc. Something like that. Fill the gaps if you see it, and so try to minimize those kind of creativity of the LLM to build something from the initial source document, something like that.
That's the answer. Thank you very much. Thank you.
Okay, and let's maybe ask, let's leave a space for one more question for today. I see raised hand, Anna.
Yep, thank you. Dzmitry, thank you a lot for your presentation. It's really useful. And I'm wondering, if it's possible using these AI agents somehow trigger calls, for example, for the, let's say, Git or Azure DevOps to understand if some story is ready and automatically start to create these cases.
In short, yes, because we had similar cases for Jira and even for Azure DevOps. If I understand properly your use case, for example, you have some Jira ticket or Azure DevOps item, and when you change the state of each item or change the assignee, you'd like to trigger the agent. Am I right?
Yep, exactly. So I don't need every time when new story is created and approved, go and trigger manually this.
Okay, so in this case, the answer is pretty simple. Both Jira and Azure DevOps have some automation rules, automation triggers. Right in the platform, you can configure them, and there might be different triggers, issue creation, assignees, changing of assignee, and so on and so forth. And this will be your trigger upon which you will call your agent through the API. For example, EliteA or CodeMe or other agentic tools have API interfaces where you can trigger those agents. Agent will be executed in the background and produce some result right inside this Jira ticket. So you won't be it won't be needed for you to go to EliteA platform or to CodeMe, and all this stuff will be done under the hood. And we did such things before and currently are doing, I would say, yes.
All right, thank you. Do we have any documentation on this part, maybe?
I will try to check, but you can go to direct messages and I will share what I have, or will share the contact of person who did this and has all the experience.
Awesome. Thank you.
Okay, so
Thank you.
that's all I think for today. And Dmitry, again, thank you for joining the conference, sharing these practical patterns with us. And dear audience, stay with us. We will have a lot of interesting talks during the conference, and tomorrow we will have dedicated day for master classes. So please join us, and thank you for being part of our AI That Works conference.
Thank you. Thank you.
Have a good day and see you.
Bye-bye. Thank you.
Bye.